In this video, we're going to be going through a few examples of straight line motion. So let's start with example 1. If you're looking for explanation for any of these pieces that we are doing, I will have in my description a video linked where I explain all of these terms. But let's go through the examples. So starting with example 1, it says a particle moves along a horizontal line so that its position at any time t greater than or equal to 0 is given by this position equation, where x is in feet and t is in seconds. Letter A says find the displacement during the first 2 seconds. So we know displacement is the change in position, so that's going to be s of b minus s of a. So in this case, we want it during the first 2 seconds. So we're going to say x of 2 minus x of 0. And I'm actually going to find each of those first, and then we'll plug in. So let's plug in 2. And I get 8 minus 20 plus 8, which is negative 4. And then let's plug in 0, and I just get 8. So x of 2 minus x of 0 is going to be negative 4 minus 8, which is negative 12 feet. Negative 12 feet. So my change in position is negative 12 feet during the first 2 seconds. Letter B says find the average velocity during the first 2 seconds. So average velocity, that is your average rate of change for your position. So that is going to be your x of b minus x of a over b minus a. So if we're using during the first 2 seconds, it's x of 2 minus x of 0 all over 2 minus 0. So this is going to be our negative 12 that we got in part A over 2, which is going to be negative 6. Keep in mind that this is a rate, so this is going to be feet per second. So my average velocity during the first 2 seconds is negative 6 feet per second. Letter C says find the velocity at 2 seconds and interpret the meaning. So whenever they ask for just for the velocity, they mean the instantaneous velocity, which is your v of t. So v of t is going to equal the derivative of my position, so x prime of t. And it's not in the screen anymore, but just to rewrite it, our x of t was 2t squared minus 10t plus 8. So take the derivative of that, we get 4t minus 10. And I want the velocity at 2 seconds. So I want v of 2. That's going to be 4 times 2 minus 10, which is negative 2 feet per second. They're asking us to interpret the meaning. Let's move this a little bit. So we're going to say at 2 seconds, your velocity describes your position. So I'm going to talk about the position. So at 2 seconds, I'm going to say the particle is moving left. We know it's moving left because my v of 2 is negative. Is moving left 2 feet per second. And there's our interpretation. Letter D, find the acceleration of the particle at 2 seconds and interpret the meaning. So your acceleration is your derivative of velocity, or your second derivative of your position. So I'm going to take the derivative of 4t minus 10. That's going to be 4. That means that a of 2 equals 4, and my units are feet per second squared. For my interpretation, I'm going to say at 2 seconds. And acceleration describes the velocity. So I'm going to say the velocity of the particle is, I'm going to say it's increasing. We know that because our acceleration is positive, is increasing 4 feet per second for every second. And that is letter D. We have a few more. Letter E says at 2 seconds, at t equals 2, is the speed increasing or decreasing? Justify your answer. So we know that the speed is increasing when velocity and acceleration have the same sign. We know speed is decreasing when velocity and acceleration have different signs. So we've already found both of these values. V of 2 we found was negative 2 feet per second. Notice that's less than 0. A of 2 we found to be 4 feet per second. And notice that's greater than 0. So since these have different signs, that means that our speed of our particle is decreasing. So I'm going to say speed decreasing because V of 2 is less than 0 and A of 2 is greater than 0. They have different signs. That is part E. Part F says when is the particle moving right and when is it moving left? So we know that the particle moves right when V of t is greater than 0, and the particle is going to move left when V of t is less than 0. So we need to figure out for what t values is V of t greater than 0 and for what t values is V of t less than 0. In order to figure that out, you want to start by figuring out where V of t equals 0 or potentially is undefined. For most of these, it's going to be when V of t equals 0 because we're going to have lots of polynomials. So our V of t was 4t minus 10. I'm going to set that equal to 0 because I want to know when V of t equals 0. I'm going to factor out a GCF. And we get t equals 5/2 is when V of t equals 0. And I'm going to set up a line chart or a sign chart. I'm going to say here's 0, here's 5/2, these are my t's, and we're going to look at V of t. I know that at 5/2, V of t equals 0. And on the between 0 and 5/2 and greater than 5/2, I want to know if V of t is less than 0 or greater than 0. So I'm going to pick a value between 0 and 5/2, just pick something easy. I'm going to pick 1. And I'm going to plug it into V of t. I'm going to plug it into the factored form because I find that easiest. And I want to see if I get a positive or a negative. So notice we get 2, which is positive. 2 times 1 is 2. 2 minus 5 is negative. So positive times a negative is a negative. So velocity is negative between 0 and 5/2. Pick something greater than 5/2, something easy. I'm going to pick 3. So my 2 is still positive. 2 times 3 is 6 minus 5 is also positive. So velocity is positive when t is greater than 5/2. At 0, notice if you plug in 0, I still get a positive and I still get a negative. So at 0, my velocity is still negative. So I'm going to include 0 in my answer. So I'm going to say the particle is moving right for t on the interval, moving right when velocity is positive. So I'm going to say 5/2 to infinity. And the particle is moving left for t on the interval, including 0, to 5/2. And that's letter F. Letter G says find the total distance traveled during the first 6 seconds. So total distance traveled is different from displacement. I want you to imagine if I have a particle on a line, and I'm going to draw above the line just to make more sense. But let's say the particle is doing this, my displacement is my s of b minus s of a. So what is this distance right here? This is your displacement. My total distance is how far did I go? Let's do a different color. How far did I go from here to here? And then how far did I go from here to here? And then how far did I go from here to here? And so on. I want to know, imagine you're jogging. If I'm jogging back and forth, how many total yards or how many total feet did I jog? What is my total distance? So that is the difference between the two. So to find total distance, there's multiple ways to do it. I prefer setting up a chart. I need t and x of t. And for t, I want my starting time, which is 0. My ending time is going to be 6 because I want during the first 6 seconds. And then in between 0 and 6, you want to include any time where your particle is at rest or any of those significant values. So if you have like an undefined, anything like that. We from part F just have the 5 halves. So I'm going to put 5 halves. And we want the position. So I want x of t. So if I plug in 0, let's put our position formula again. Or position equation, I should say. If I plug in 0, I'm going to get 8. And then I'm just going to tell you, 5 halves is 2.5. Maybe we'll think of it as that. If you plug in 5 halves, you get negative 4.5. Like if I did x of 2.5. And then x of 6, when you plug in 6, you get 20. Okay, so what you want to do is you want to look at the changes in position between each of these. So at time is 0, I'm at position 8. At time is 2.5, I'm at position negative 4/5. So if I travel from 8 to negative 4/5, I have traveled 12.5 units. We're in feet, so I've traveled 12.5 feet. And then between 2.5 and 6 seconds, I travel from position negative 4.5 to position 20. I've traveled a total of 24.5 feet. And I want total distance, so I'm going to add these together, and I get 37 feet. That is your total distance traveled. So this is example 1. We've got a couple more. For example 2, it is super common for them to give you a graph like you see here. And the graph is usually either the position graph, so graph of position over time, or graph of velocity over time. So for this one, it says the graph shows the velocity, v of t, of a particle in feet per second, moving along a horizontal line for t between 0 and 8 seconds. So let's just go through them. Letter A, if I have this labeled, let's label this first. So my x-axis is in t, which is seconds, and my y-axis, this is my velocity. Letter A says, what is the velocity at 6 seconds? So at 6 seconds, at 6 seconds, my velocity is right here, and that is negative 2. So v of 6 equals negative 2, and I am in feet per second. We want to interpret it, so I'm going to say at 6 seconds, the particle is moving left. I know we're moving left because my velocity is negative, is moving left 2 feet per second. Letter B, what is the acceleration at t equals 1 second? Well, here's t equals 1. Acceleration, we know, is the derivative of velocity. And so for this graph, acceleration is going to be the slope of velocity, or the slope of this graph. So I need my slope at this t value. And we can count rise over run. This is a line. So my slope is going to be 1 over 1, which is just 1. So we're going to say a of 1 equals 1. And my units are going to be feet per second squared. To interpret it, I'm going to say at t equals 1 second. Acceleration describes velocity, so I'm going to say the velocity of the particle is increasing 1 foot per second per second. Letter C says, when is the particle moving right, when is it moving left, and when is it at rest? So we know a particle is moving right when the v of t is greater than 0. We know it's moving left when v of t is less than 0. And we know it's at rest when v of t equals 0. So let's start with v of t greater than 0. That's going to be wherever this graph is above the t-axis, the x-axis. So I can say that the particle is moving right for t's in the intervals 0 to 4, and this is 7 right here, and 7 to 8. I'm including 0 and 8 because I have closed circles at 0 and at 8, and I can verify that my velocity is positive at t equals 0 and t equals 8. For when is the velocity moving left, that's going to be where my graph is below the x-axis, below the t-axis. So that's going to be for t in 4 to 7. And I'm not including 4 or 7 for any of these because that is where my velocity equals 0. That's where your particle is at rest. So I'm going to say my particle is at rest for t equals 4 and t equals 7 seconds. For letter D, when is the particle's speed increasing and when is the particle's speed decreasing? So we know that the speed is increasing when v of t and a of t have the same sign. So let's look at these. I'm going to make this blue. So notice here from 0 to 2, your velocity is positive because my graph is above the x-axis, and your acceleration is positive because the slope is positive. So velocity and acceleration are both positive, so my particle speed is increasing from 0 to 2. Notice same thing from 7 to 8. My velocity is positive because I'm above the t-axis, and my slope is positive, which means the acceleration is positive. Also notice between 4 and 5, my velocity is negative because I'm below that x-axis, and the slope is negative, so my signs are the same as well. So my particle speed is increasing for t in, I'm going to say 0 to 2, 4 to 5, and 7 to 8. Notice here I did not include 0 and 8. That is because the derivative doesn't exist at 0. The derivative does not exist at 8. So I don't know what my acceleration is at 0 and at 8. So I can't verify if the signs are the same or different. Let's do when the speed is decreasing. Or let's do a different color. Let's see. We'll do purple. So my particle speed is decreasing when the sign of velocity and acceleration are different. So notice here between 2 and 3, my velocity is positive because I'm above the t-axis, and my acceleration is negative because the slope is negative. That is also true here. And that is also true right here. Between 6 and 7, my velocity is negative because I'm below the t-axis, but my acceleration is positive because the slope is positive. Notice that at t equals 3, my derivative doesn't exist because my slope from the left doesn't equal my slope from the right. So I'm not going to include 3 in my answer. So I'm going to say 2 to 3, 3 to 4, and 6 to 7. Letter E says, at what time does the particle change directions? So we know the particle changes directions when v of t switches between positive and negative. So here at t equals 4, v of t switches from positive to negative. And at t equals 7, v of t switches from negative to positive. So at 4 and 7, my particle changes directions. So the particle changes directions at t equals 4 and t equals 7, because velocity switches between negative and positive. And that is an example when you are given a graph. We have one more example. For this one, it says the particle is moving along a horizontal line. They gave us a position equation for t greater than 0, where s is in meters and t is in seconds. We want to know when the particle is moving left and moving right, also when the particle's speed is increasing and decreasing. So for moving left and moving right, we need to look at the signs for v of t, just like we did it in the first example. So I'm going to start with my s of t, and I'm going to take the derivative of that to get my v of t. I'm going to set my velocity equal to 0 so I can see where my particle is at rest. And I get t equals 0 and t equals 2. So I have two places where the particle is at rest. I'm going to make a number line. I have t along my number line. I'm going to have t equals 0 and t equals 2. So my particle is at rest at 0 and 2. I'm going to make that my v of t. And just like we did in example 1, I'm going to choose values between these numbers to test. So between 0 and 2, I might choose 1. I get a positive. 3 times 1 is positive. 2 minus 1 is positive. So between 0 and 2, my velocity is positive. After 2, I might pick 3. 3 times 3 is positive. 2 minus 3 is negative. So my velocity is negative for t's greater than 2. So I can decide that my particle is moving left for t's from 2 to infinity, and my particle is moving right for t's from 0 to 2. And we decided that velocity equals 0 at 0, so I'm not including 0. That is part A. Part B says, when is the particle's speed increasing or decreasing? We know that the speed is increasing when the signs of acceleration and velocity are the same, and decreasing when those signs are different. So now I need to figure out acceleration. So I'm going to take the derivative of my velocity equation, and I'm going to set that equal to 0. So I can see where my acceleration equals 0. And on either side of that, my acceleration could change. So I get t equals 1. So I'm going to add it to my number line up here. T equals 1, and I'm going to say my acceleration equals 0 at t equals 1. I'm going to test something now on either side of 1 to see my signs for acceleration. And then I want you to notice we are going from t greater than or equal to 0. So I'm not going to choose a negative number to plug into a of t. So I might pick 1/2. If I plug in 1/2, I get a positive times 1 minus 1/2 is also positive. So my acceleration is positive between 0 and 1. But after 2, I might choose 3 again. When I plug in, I get a positive and a negative. So acceleration is negative to the right of 1 for t's greater than 1. Now let's decide, when is my particle speed increasing, when is it decreasing? So let's figure out increasing first. That's when my signs are the same. Notice between 0 and 1, my velocity is positive and my acceleration is positive. So my speed is increasing there. And then also notice for t's greater than 2, my acceleration is negative and my velocity is negative. So I'm going to say my speed is increasing for t's on the interval 0, 1 and 2 to infinity. My speed is decreasing between 1 and 2 because my velocity is positive, my acceleration is negative. Those signs are different. So I'm going to say speed is decreasing for t's on the interval 1, 2. And that is speed increasing and decreasing. So these are a few examples of particle motion. Thank you for watching this video.